Hello Bandhugan, Namaskar. Welcome back to my YouTube channel, Sahil Educations, and I'm Sahil. In this video lecture, we'll be learning about the isomers of monosaccharides as we are just going through the series of biochemistry and carbohydrate chemistry exactly. So first, we'll discuss about isomers. Isomers are the compounds which do have the same kind of empirical formula, but their structural formula or structural constitution is something different. Their spatial arrangements are something different. Then the form of monosaccharides can be called as isomers. Like you can say glucose and fructose. Glucose and fructose do carry the same empirical formula, that is C6H12O6, and they do have two kind of functional groups. One is aldehyde and another one is ketone. So let's start with glucose and fructose and these isomers. So isomers can be differentiated into two forms. One is constitutional isomer and another one is stereoisomer. Constitutional isomers, when the compound do contain different kind of functional group, then this can be called as constitutional isomer, in which we can see one is glucose and another one is fructose. Yes, obviously we have already discussed that glucose do contain aldehyde as functional group and fructose do contain as functional group, that is ketone. When we come to stereoisomer, stereoisomers do have the same kind of functional group, but their spatial arrangements of hydroxyl groups and hydrogen atom are somehow different. Definitely there may be a various number of stereoisomers depending upon the number of chiral carbons. What are chiral carbons? So you have to go back and see my previous videos upon the chiral carbons and all. So based upon the number of chiral carbons, there are many numbers of stereoisomers can be formed. In case of glucose, there are 4 chiral carbons, so 2 to the power 4 equals to 16. So in case of glucose, there are 16 possible stereoisomers. Okay. Then we'll divide stereoisomers into two different forms. One is enantiomer and another one is diastereoisomer. So well, in case of enantiomer says that if the hydroxyl group is present in the right side, the hydroxyl group of penultimate chiral carbon. What to say? Penultimate chiral carbon's hydroxyl group is present in right side of the backbone, then that compound will be called as D form of that monosaccharide or compound. And if the hydroxyl group is present in the left side, which hydroxyl? That is the penultimate chiral carbon. If we draw it like, if this is the glucose Fischer projection, this one is the penultimate chiral carbon, and if OH is present in right side of this backbone, then this can be called as D form. And if the compound has OH in this chiral carbon in the left side, then it will be called as L form. Remember it is not small d or small l. If we talk about small d and small l, then it will come under optical isomerism or optical isomers, that is dextrorotatory and levorotatory. In this case, capital D is not equal to small d. Okay. Then coming to diastereoisomers, definitely when there is a change in the hydroxyl group in the chiral carbon, the penultimate chiral carbon, there must be some kind of change may happen. Some kind of change may happen in these chiral carbons also. The OH and H may be present in right or left. The spatial arrangement of OH and H may be changed or may differ from one another of a single monosaccharides, different stereoisomers. So all these, other than the enantiomers, all these are diastereoisomers. It comes under diastereoisomers when, let's take an example, like if these are the diastereoisomers. How these are the diastereoisomers? One has OH, 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 OH. One has OH, 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 OH. One has OH, 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 one has OH, OH, OH and OH. Let's take example like this. OH goes to the left. All these are the diastereoisomers of glucose. Okay, so this is how diastereoisomers can be defined. Diastereoisomers are again divided into two different types. One is epimer and another one is anomer. Epimers are the compounds which differ the hydroxyl group. Actually, the chiral carbon, at one chiral carbon, if hydroxyl group is different, the position of the hydroxyl group is different, then these two compounds can be called as epimer. Just take an example like this compound and this compound. This is allose and this one is altrose. Okay, here carbon number 2, that is chiral carbon, first chiral carbon has OH in both the compounds have OH in right side, but the chiral carbon number 2 and the carbon number 3, that is OH is present in the left side of altrose, and in case of allose the OH is present in the right side. So these two compounds are epimeric or epimer with each other, and the epimeric carbon is the carbon number 3. Okay, so this is epimer. What is anomer now? Anomers, if you have seen the lecture of Haber's projection and Fischer projection, then you must have seen that there may be two kind of Haber's projection. What are the kinds? If we draw the Haber's projection here, this one is the number 1 carbon and this is the 6th carbon. One carbon has OH in the downward and the 6th carbon has OH in the upward direction. If the OH of 1 and 6 stays apart, then this is alpha form, alpha anomer. And if the OH and OH of first carbon and the 6th carbon stays close with each other, then it can be called as beta form of that compound. Okay, so this is how alpha and beta differ with each other. So this is all for the isomer part. In the next video you will have some kind of tricks in which through which you can draw your Fischer projection very easily till glucose and its diastereoisomers. So be with Science Educations and enjoy learning. Please comment your suggestions. Thank you.